Hello guys, my name is Nipun Sharma. I'm working as an assistant professor in EC department. Today I will tell you about the basics of Proteus software, how we can use it for our circuit designing and testing our circuits. So let's get started. So before going to the software, we are having some important terms related to the software. This software is basically introduced by Lab Center Electronics. And the first term we are having is ISIS. The meaning of this term is Intelligent Schematic Input System. Next is LISA, Lab Center Integrated Simulation Architecture. And the last is ARES, Advanced Routing and Editing Software. So basically these things define about the software. It is basically an intelligent schematic input system software. So basically it is used by the various electronic and electrical industry to simulate the new designs, new circuits that are used. And I think most of the research students are also using this software for designing their new circuit and to test them. So Proteus is a product of Lab Center Electronics. The Proteus design suite combines ease of use with a powerful feature set to enable the rapid design, test and layout of professional printed circuit boards. With the use of this engineering software, you can construct and simulate different electrical and electronic circuits on your personal computers or laptops. So it gives you independence about the circuits, how you can design new circuit, test them without wasting the very heavy and very, you can say, expensive equipments. So why we are using the Proteus software? What are the advantages of Proteus software? We should know why we are using. So Proteus has many advantages as follows. Designing of circuits on Proteus takes less time than practical construction of the circuit. The possibility of error is less in software simulations such as loose connection that take a lot of time to find out the connection problem in practical circuit. Circuit simulation provide the main feature that some components of circuits are not practical, then you can construct your circuit on Proteus. So the thing is that if we want to design a new circuit and we are not want to waste the equipments, or we are having that these circuits can burn, so we can test them on the Proteus software first and then we can design them in the reality. So another thing is, what is the importance in research and industry? Proteus has been widely in research and industry by professionals and research scholars all over due to its reliability and able to design and simulate circuits with perfection. So research scholars, in fact, when they are researching for a new circuit, they try to do it first simulation of the circuit, and this is, I think, the best software our research fellows are using, because it's you can say the results on the Proteus are almost similar results we are getting on the practical circuits. The error is very less. I think I have personally used this Proteus software and you can say the error is very less. What are the features of Proteus? There are two main parts of Proteus. First is used to design and draw different circuits, and second is for the designing of PCB layout. The full form is PCB is printed circuit board. First is ISIS that used to design and simulate circuits, and second is ARES that is used for designing of a printed circuit board. It also provides features related to three-dimensional view of design in PCB. So basically it is also used for PCB designing. You can use this Proteus software, and this is the most important thing in Proteus, that the modes, different modes. So we are having the selection mode, component mode, junction dot mode, wire level mode, text scripture mode, buses mode, subscript mode, terminal mode, device pin mode, graph mode, active pop-up mode, generator mode, pro mode, instrumentation mode, and last are the 2D graphics. So these are the different modes that are used in Proteus, and it takes a lot of time to understand these modes because it is a full software and requires your full dedication about the different modes and different components, because in electronic industry we are having so much models of the electronic and electrical equipment. So while using these modes we should have the vast knowledge about the mode, what are the different purposes of these modes. So so first we can say we are having the component mode. In component mode we can usually see the different components that are present in this our software. So these components are like resistor, capacitors, other inductors, whatever the circuits that we used to make the circuits, all these components are present in component mode. And we can add different components through library also, update the component mode through library also. To simply select the component, we just click on the P mode, and then we just select the component, which component we want. Suppose we want a capacitor, we have different kinds of data there. We can use inductor, memory, IC. The thing is that we should know the model of the exact model of the component. Just you can say the electrical model of the component. Like for the LED, it's not we are having different kinds of LED. Capacitor, we are having ratings of capacitor. Resistor, we are having ratings of resistor. So first we should know what rating of the component we are finding. So simply we just put like word resistor there and check for the rating is for 10K, 1K, like that. Then we are having the components list on the screen, and we can choose the component required for our circuit connection. Like we get all types of components here, like for 10 ohm, 20 ohm, resistor, temperature sensor, means with a very less difference we get many components, and we should know the exact component model name. So we can select there, and then comes the ISI instrument mode. In instrument mode, we are having different kinds of instruments like we see oscilloscope, signal generator, logic analyzer, pattern generator. So all these instruments are very expensive in reality. But here we can check our waveform on oscilloscope. We can generate a signal like on a signal generator. We are having virtual terminal. We are having DC voltmeter. We are having ampere meter. So all these components are working like we are having a real voltmeter. So all these are virtual but behave as working as a real. Then we have the terminal mode. In terminal mode we are having different terminal input, output, power, ground, bus that are used for in our circuits, for grounding, for giving power in the circuit. So these are the different modes. And then we are having the simulation section. In simulation section we are having the different steps like play, step, pause, stop. So when we play the circuit, it's actually giving simulating the circuit what is actually generates the output for our input circuit. So we can also pause our circuit, we can stop our circuit. So these are the different simulation techniques that are used in this Proteus software. So then comes how to save our design, how we can save our circuit. we can save our different circuits and use them later. So these are the steps. Just simply go into the file and just save your schematic circuit. And this is the example of one LED simulation, simple LED simulation circuit. So first you should know the components and their models, and you just select the models and put it on the software, and after that connect the components using the wire. We are having the wire connections, so just connect them through the wire. And simply you can also change the voltage levels of the battery through added component that is present in the software. So by changing the voltage level battery, there is a lot of effect on the output. And the last is we are having this circuit completing on, there is a play button here. When we play the circuit, there will be LED will be glowing, so that tells that if we are using 5-volt battery with a switch and 330 ohm resistor, we get a LED flashing. So we can actually create this circuit in reality also by first checking this circuit on the, you can say, software. So our main purpose, that was simulating the circuit, checking our circuit, has been completed like LED simulation circuit on the software. So we can make other circuits also by using these techniques and check the output and what are the effect of different components in the circuit. We can readily check here. Thank you.